Good evening, everyone. It's great to see you all here at the pub to talk about lifestyle diseases. I hope you've all got a drink. We can cheers to that. This is our second Science in the Club, third actually for 2017 if you include Pint of Science, and happy National Science Week. Woo! It's National Science Week all throughout Australia, and over the last 6 to 7 years the Australian government has supported events like this one, and we are funded and supported by Inspiring Australia, who make these National Science Week events happen, so that there are over 700 events recorded in National Science Week across Australia, of which we are but one. And I like to take this week to reflect on why it's important to have a week of science, and so you might have your own reasons for celebrating science, but for me, understanding and why and how science can help save lives over and over again, improve lives over and over again. And you'll hear a lot of statistics tonight about how that's happened, and I think that's worth celebrating for a whole week, not just a day. And tonight I'm really happy to be joined by experts and people who have saved lives, and I feel very humble to be talking to them tonight. So thank you to Inspiring Australia and the New England Northwest Regional Science Hub for hosting these. We had 3 last year in Science in the Club, as I said, second one for this year, and at the end I'll do a bit of a spruik for the next ones, but we're talking about toxic animals and then dinosaurs over the next couple of months as well. When you walked in, you would have received an orange raffle ticket. Please keep it, because we do a lucky door prize draw at the end for a year-long subscription to Cosmos magazine. So hold tight to that one. And I won't blab any more, because I want to introduce tonight the science of lifestyle diseases, something that affects all of us. And something that I think is becoming, well, not I think, but the statistics say is becoming more and more of an issue in not just Australians, but everyone in the world's lives. Australians are living longer than ever, but we're living with more chronic disease, and it's costing a lot more. I want to highlight that in front of you, you have the profiles of our panel members, which I'll introduce you to in a minute. But you've also got some highlights from a 2016 kind of health report card, if you like. And I want to highlight this because it's got some really interesting statistics that you might be unaware of, but also when we have a break at 8 o'clock and do some trivia, a lot of the answers to the trivia are sort of hidden in these statistics. What I do want to point out that it's not all bad news. In the last, just over 100 years, our life expectancy has gone up almost 40 years. If you were a male in 1890, your life expectancy was only 42 years, but now it is just over 80. And so that's really good news, if that's the kind of metric where we're measuring how far we've come in lifestyle diseases. However, coronary heart disease is becoming more and more widespread and is still the leading single cause of death in Australia. We'll talk more about how to unpack those statistics tonight though. So without further ado, I'd like to introduce our panel of experts tonight. On my left we have Associate Professor Michelle Guppy, and as you can see on her panel, she's a GP as well as an academic at UNE, and this again I think it makes me feel very humble in Armidale. We're very lucky, and in fact choosing members for the panel was really hard. We have a pool of amazing medical professionals in Armidale, not only GPs but researchers and people who can do evidence-based medicine at a research institution and practice that and save lives in the community. I'm just in awe. Michelle Guppy. We have Dr. Jacqui Epps, who does the same thing. Jacqui has actually taken on more research and some research now into diabetes, but has been a practicing GP in rural areas in New South Wales for decades. And our head of the School of Rural Medicine at UNE, so Professor Rod McClure, thank you for coming tonight and lending your expertise. And Rod's breadth and depth of expertise in lifestyle diseases and a lot of other, which I won't even go into, aspects of medicine is a huge asset for Armidale to have too. Now, I've asked the panel to give us a little bit of a spiel about why they're interested in medicine, lifestyle diseases, and what it means for them in their research. So I'm going to hand over to Jacqui Epps to kick off the science of lifestyle diseases.
Well, thank you very much, Kirsty, and thank you everyone for coming along tonight to listen. I thought I'd start off just with a basic introduction about what lifestyle diseases are. So I actually had quite an extensive look on the internet just to see what people thought lifestyle diseases are. And there was actually very few definitions, but I did find one, which just says diseases whose occurrence is primarily based on daily habits of people and are as a result of an inappropriate relationship of people with their environment. I thought that was okay, but I thought that inappropriate word was perhaps just a bit judgmental. So see what you think. So what are lifestyle diseases? Look, I'm sure a lot of you are already very familiar with this list. If I move. Yes, I'm sure a lot of you will be familiar with the diseases on this list, either just through personal experience or family experience, or just friends and families who might have been affected by these. But I've put the list up here partly to explain that the list goes on. There's more and more that are becoming apparent as lifestyle diseases as we learn more about how these diseases are caused. And I think in another 5 or 10 years, that list will be even a lot longer. For example, we now know that probably up to 80% of cases of cancer can be caused through lifestyle factors, which is a big statistic which is only becoming more increasingly obvious. So what's the scale of the problem? Why is this actually important to be discussing tonight? Well, according to the World Health Organization, lifestyle diseases causes a much greater public health threat than any other epidemic known to man. Now, that's a big statement by the World Health Organization and something to reflect on. Back in 2008, 63% of global deaths were as a result of lifestyle disease, and lots of these were a young age, and this number is only going to go up. It's getting worse, unfortunately. So what are the causes of these lifestyle diseases? Let's just step back a little bit for a minute. A lot of you might have heard about germ theory or pathogens. So, for example, we know that if you've got chickenpox, that there's a particular virus that's responsible called varicella zoster. Without that virus, you don't get the chickenpox. That's fairly straightforward and reasonably simple to understand. But with lifestyle disease, it gets a little bit more complex. There's a good professor called Professor Egger in Lismore, I believe, who is a lifestyle physician, and he's come up with the term anthropogens, and I think it's quite a good term. He sees these as the cause of lifestyle disease. Essentially, these are lifestyle factors that induce disease, and they cause low-grade chronic inflammation, and anthropogenic actually means made by humans. Do you want me to move across? Okay, so where are these coming from? Well, it's actually a bit of a mixture of good and bad news for the Earth. With successive treatment of so many diseases around the world over time, particularly infections, people are living longer. We're curing a lot of diseases. There's a lot of problems like malnutrition, which are no longer an issue in some fortunate countries, but not all, that's for sure. Of course, there's the Industrial Revolution, and people are living longer. That's some of the reasons for this. So while there's good news, we've got rid of a lot of disease, on the flip side, there's now a lot of newer diseases emerging, and the proportion of that is different between different countries. I don't think these lifestyle factors need a lot of introduction. I'm sure you probably could have quoted these yourselves as what common cause of lifestyle disease are, and I think you'll probably recognise a lot of those pictures there too. So, how about Australians? How do we fare with lifestyle risk factors? Just a quick check. How many Australians achieve the recommended 5 minimal vegetable servings per day, do you think? I think they actually announced this in the supermarket if you've been listening. Any rough pictures for that? It's pretty low, 10%. 10%. That's pretty scary. How about fruit? We all like fruit. What do you reckon? 80%? No, 50%, and that's fruit. Well, Australia loves exercise. How many Australians would meet the target of 150 minutes per week of exercise? 40%. That's pretty depressing. And how many Australians spend 3 hours or more of their leisure time sitting? 80%. What are we doing? Okay, so we've just discussed some common lifestyle factors there, but are they all of them? Well, actually not. And again, our Professor Gary Egger has put together this nice iceberg diagram. Up the top here, you'll see things like nutrition, activity, drugs, smoking, stress up there. The top of the iceberg that's pretty visible, most of us know about those. But as time goes by, there's some interesting ones that have turned up. So you've got occupation, the environment, relationships, social inequality, emerging one there, exposure or underexposure to quite a few different things, and that could be sunlight or asbestos or various things there. But the other thing you'll notice about this rather complex diagram is that these all affect each other. And I think that has big implications in how we manage and treat these lifestyle diseases and lifestyle factors. And it also shows these things rarely occur in isolation. So if we're trying to fix one thing up here, we have to consider all these other factors down here rather than just targeting that. So it's obvious this is a big problem. There's no doubt about that. We know what we need to do, I think, and there's good evidence to show that if we improve the situation, that people will be healthier. For example, the anti-smoking campaign has done really well. We're not there yet, but we've noticed some good improvements. So why is there such a lag from many other lifestyle factors? What if I told you that there was this treatment that was shown to prevent type 2 diabetes in really high-risk people by 58% compared to placebo? 58%. What if I announced that? And that it was safe, that it was very cost-effective, and it was a big study? That should be plastered all over the headlines, right? The big pharmaceutical companies would have a lot of interest in that. So what's the wonder drug? 30 minutes of walking per day and losing 5 to 7% of body weight. Now that's a pretty staggering number. And let's compare that to the drug that you can use for the same people, metformin. There's only a 31% reduction in diabetes there. So why aren't we succeeding? And why isn't the message getting out? The World Health Organization says that 80% of premature heart disease, stroke and diabetes can be prevented. And to finish off this section, I'd like to quote from Garriega here that victim blaming tends to absolve governments, health bodies and big business from any blame from the modern chronic disease epidemic. And that might be something we might touch on a bit later. Now, Kirsty has asked me just to briefly talk about my research interest area at the moment, which is in diabetes, of course, which is a lifestyle disease, type 2 diabetes. And I'm sure that everyone here has experienced acute pain and been thankful to take painkillers to be rid of the agony from that pain. But unfortunately, evidence now shows that avoiding discomfort might actually have a significant downside. Painful sensations can actually protect the body. People who have short episodes of chest pain before a heart attack sustain less damage from the heart attack. Animal studies have shown that a small cut made on the skin, just a superficial cut before a heart attack, reduces the amount of heart damage that we get. Stimulating these pain-sensing nerve fibres with other noxious stimuli, like chili paste on the skin or a temporary lack of blood flow to a limb, intense exercise, or even direct electrical nerve stimulation to those nerve fibres themselves is actually also protective. Plus, if this nerve that senses these noxious stimuli is blocked with local anaesthetic, the protection's lost. So why is it so? Well, there are probably quite a few mechanisms. Recent research shows that some nerves in our body send signals to the bone marrow after a noxious stimulus. This leads to special cells called endothelial progenitor cells, or EPCs, those are the ones you can see in the background there, being released into the bloodstream and attracted to the site of harm. These cells quickly grow new blood vessels to heal the damage and increase blood flow. At the risk of sounding just a bit masochistic, in this way, acute pain can be good for us. It also makes sense from a species survival and adaptation point of view. But what about people who can't feel pain or have less feeling for pain? It's been found that by temporarily but harmlessly stopping oxygen-rich blood flow to a limb provides protection from a subsequent heart attack or stroke. This is called ischemic conditioning. But it's often not protective in diabetic patients or animals. There are clues that nerve pathways are important in ischemic conditioning. Diabetics don't get the crucial rise in these endothelial progenitor cells after exercise or after a heart attack. They don't get the same protection from angina preceding a heart attack. And in diabetes, the nerve fibres in pain pathways are frequently damaged. Called diabetic neuropathy, this causes a decreased ability to sense the noxious stimuli and relay those signals. We know ischemic conditioning doesn't provide protection from heart attacks in the presence of diabetic neuropathy. But why? Could the impaired pain signals preventing activation of these beneficial cells be a factor? In my study, I'll be assessing the effects of the presence of diabetic neuropathy on the changes of these endothelial progenitor cells following ischemic conditioning. If my hypothesis is correct, the presence of decreased sensation in the limbs or in the central nervous system will prevent a rise in these endothelial progenitor cells. This might have implications for the evolving therapy of ischemic conditioning and diabetic sensory neuropathy as a cardiovascular risk factor. Finally, it might also have implications for the safety of some painkillers, and that does make me feel uncomfortable. Let's just hope I'm wrong on that one. Thank you.
Thanks, Jack. Thank you, Jacqui. I don't know about you, but I might just stop I feel like I need to stop every 5 minutes. Everybody get up, do 10 star jumps, we'll walk around the room, and then we'll sit back down again. So feel free to stand up and do that. So a lot of those statistics are alarming, and thank you for introducing those now, and we can start to unpack those. Now, I'm going to move on so that each panel member has an opportunity to introduce their interests and things like that. But I'm going to throw to Q&A from you guys straight away because I don't need to kind of introduce questions. So please keep questions in mind while I pass on to Michelle.
Thank you. Hello, everybody. It's really great to be here tonight. I probably consider myself an applied scientist rather than a true scientist. So I'm not a biochemist, that's just a little disclaimer at the beginning. I'd like to talk a little bit about diabetes, but I'm going to talk about it in very straightforward terms, in the way I'd explain it to a patient. I'm a GP. I've mainly worked at the University Medical Centre, so mostly had very young and healthy patients for most of the time I've been here in Armidale. So I actually haven't had a lot of diabetic patients myself, only a handful. But diabetes is such a prevalent disease, and I find it really interesting to look at why people get diabetes. I'm not sure if any of you have diabetes. If you do, you may be aware that for 17 of the last 20 years, the GPs in Armidale and in the New England region have run a chronic diabetes program in helping GPs manage patients with diabetes. We have had 4,000 patients in this region with diabetes on that program. And we've basically monitored those people for 17 years and looked at how GPs have been managing those patients, and been able to evaluate that program and then feed that information back to the GPs in the region so that the GPs can see how well they're managing their patients with diabetes. And so that's what I mean by applied science, is that you have a hypothesis, you look at what you're doing and how you're managing people, and you feed that information back to the people on the ground who are treating disease so that they can change what they're doing. So unfortunately, the funding for that was cut in 2014, and I've spent the last 2 years trying to find more funding to restart it. Managed to get some to restart it for 18 months. So I've been actively re-enrolling patients on that program over the last 6 months. I'm still looking for more funding to keep it going beyond the end of this year. But it's something that I think is really, really valuable, and I've been looking at all the data. I've been sending that data back to GPs to show how well they're managing their patients, and they have found that very valuable. So that's my interest in diabetes. I understand that there are a number of people here without a sort of medical background, so I thought I would very briefly just go over what the problem is with diabetes, so that we're all on the sort of same playing field. Because then I want to talk about obesity, which I also find very fascinating, and I find human behaviour very fascinating. And I don't think that all of us over the last 30 years have suddenly become lazy slobs when people weren't lazy slobs 30 years ago. So I think there are some really interesting causes on why obesity has been increasing over the last 30 years. So I'm not sure how to activate my slides.
Because in the meantime, I actually want to ask you, Michelle, how common is this tracking of how well GPs are going in regional areas or in regional Australia? Is this unique in the New England area, and how are they going? What's the data set?
So the other disappointing thing about losing the funding for this project was that it's actually unique in Australia. And so it was the only program that was still running in Australia looking at diabetes in general practice patients. So there's lots and lots of studies of patients who have diabetes who go to hospital outpatient clinics and how they're managed there. But those patients tend to be sicker than patients with diabetes who are managed by their GP. So we've got lots of data on sort of quite sick patients with diabetes, but not on the sort of general average patient with diabetes. And so it was a unique data set. Not so far. My boss might give me some money to travel overseas to present it sometime. So I just very briefly wanted to go over what the problem is in diabetes. And like I said, I'm not a biochemist, so I know there are a few people in the room who know more about biochemistry than me, and feel free to correct me. So this is a... Do I have a little pointer here? Press the wrong button. That one? Yeah. So this is a picture of the pancreas gland, which sits just in the sort of apex of your abdomen, right next to your stomach. And it has two main functions. One is to release digestive enzymes into your duodenum when you have a meal. And then the other is to release hormones into your bloodstream in response to eating or in response to fasting. The hormonal part of the pancreas gland is called the islets of Langerhans, and there are alpha and beta cells in the islets of Langerhans. The alpha cells release a hormone called glucagon, and the beta cells release the hormone that you're all familiar with, which is called insulin. Now, the way insulin works is in response to carbohydrate in your meal, the carbohydrate gets broken down into glucose molecules in your small intestine. That glucose goes into your bloodstream and is picked up by these beta cells in the pancreas. The pancreas releases insulin. And then the insulin goes to, around in your bloodstream, to the cell membranes of cells all around your body. And the action of insulin is to bind to a receptor on the cell wall, and then that releases a whole cascade of processes that I won't go into that then open up a transport molecule that's called GLUT4 on the surfaces of those cells, and that GLUT4 is what allows the glucose that's travelling around in your bloodstream to enter the cells. And all the cells in your body use glucose then as fuel. There are a few cells in your body that don't actually need insulin to get into the cells. They've got a different type of receptor called GLUT1. That's your liver, so glucose can go into your liver without insulin. The brain cells don't need insulin, and glucose is the primary fuel source for your brain, so it can just go straight into your brain to be used as energy for your brain. Red blood cells also don't need insulin to get into them, and so one of the blood tests that we do to measure how high a patient with diabetes blood sugar level is over a long period of time is something called HbA1c, which is a measure of how much the glucose is affecting their red blood cells. So what happens in diabetes? I'll just get out of the way there for a second. In type 1 diabetes, there's two types of diabetes. Type 1 diabetes is a disease, it's called an autoimmune disease, where there is an immune system reaction against those beta cells in the pancreas, and the body's own immune system attacks those beta cells and kills them, and the patients very quickly have a complete lack of insulin production in their bodies. There's a very strong genetic basis for type 1 diabetes, and type 1 diabetes is not the epidemic that we're talking about tonight. We're talking about something called type 2 diabetes, which has a different mechanism. So there is still a genetic predisposition to developing type 2 diabetes. It's probably not quite so strong as type 1, but it is there. And then obesity is the other huge driving factor in the development of diabetes. So you need the genetic predisposition plus obesity. Yes, there are some type 2 diabetic patients who aren't obese, but by and large obesity is the factor that is driving it. And what happens is that the insulin that's produced by the pancreas in response to a carbohydrate meal doesn't work as effectively to transport glucose across the cell membranes in the presence of high levels of fat in the tissues. So if you have high levels of what we call visceral fat, so fat around the organs in your abdomen, fat in your liver, and generally fat around the organs in your abdomen, that creates a situation called insulin resistance. Fat under your skin doesn't appear to be so much of a problem as the fat around your organs. So what happens to the pancreas is the insulin's not working as effectively, so the pancreas increases the size of the cells to try and pump out more and more insulin, and then eventually, as a person's diabetes progresses, those cells fail to produce as much insulin and they can't keep up with demand. The other thing that happens in the liver is normally the liver stores glucose when there's lots and lots of glucose going around. And so if the glucose isn't being used by the other cells, the liver stores lots and lots more glucose. And as a byproduct of the liver storing glucose, it also converts some of that to what's called triglycerides. And triglycerides are one of the bad fats in our body. Triglycerides and another thing that's called very, very low density lipoproteins, or VLDL. And those are both associated with coronary heart disease and with cardiovascular disease. So there's the main thing that kills people with diabetes is actually cardiovascular disease. So it's the lipids, the high levels of lipids in their blood associated with atherosclerosis that then causes strokes and heart attacks. The thing that causes a lot of morbidity, so unwellness in people with diabetes, it can directly be the effect of the high glucose on the microvasculature. So it can affect people's eyes, it can affect people's kidneys, it can affect people's sensation in their feet and those sorts of things. So there's a couple of different mechanisms going on. So that's diabetes in a nutshell. Yeah. Now, the reason I wanted to talk about to talk about obesity is because it is one of those huge drivers of diabetes. And the thing I find really fascinating, and the question that I really want to know the answer to, is why has obesity become such a problem, and it's only been in the last 30 years? So these are some stats from Australia. So if you look back in 1989, the obesity rate in Australia was only 11%, and now it's about 28%. So over that period of time, it's over doubled. And then if you add overweight and obesity together, back in 1989, it started at 44%, and it's gone up to. These stats are from 2012, but I think it's the same on The stuff that Kirsty gave you, it's still 63%. Yeah, yeah. So I find that fascinating. I think that's really, really interesting as to why. I mean, and it's all of us. 63%. It's all of us. It's not just the lazy ones of us. It's all of us who've become overweight. And we might have a bit of a discussion about that, I think, because I think that's a really interesting question. All right, so the way they're defined by this study is by something called your body mass index. And a body mass index is basically the ratio of your weight to your height squared. So you do a calculation, you work out your weight, and then you square your height and divide it. And what's considered normal is 20 to 25. What's considered overweight is 26 to 30, or 29, is it? 29, 30. And then what's considered obese is over 30. Yeah. So you can do that. You can just Google a BMI calculator and plug in your height and weight, and you can get that calculation. Your height has to be in metres. So there's, yeah, so look, it's a little bit controversial, and probably a better measure of your fat levels is your waist circumference. But I guess, unfortunately, a lot of studies still use BMI as their parameters. As GPs, we are advised to do both measurements and keep a record of both measurements. So for men, I think their waist circumference should be under 93 as a healthy weight, and for women it should be under 83.
Michelle,
Yep.
looking at this graph, the graphs sometimes are misleading, but it looks as if the overweight population hasn't increased. It looks as if it's only the obese population that has increased.
Yeah, that's interesting. I have those numbers somewhere, not in my head right at the moment. So, but yeah, from that graph, I agree with you. It doesn't look like this orange line has changed very much, does it? But
Because that would be a different problem if that were the case, yeah?
it's just, I think it's degrees of the same problem. It is all a continuum, and I think these numbers, those cut-offs between overweight and obesity, it's a continuum. It's not you've suddenly got one risk in one category and a higher risk in the other. Look, the other thing I just want to pose as a question as well, and it'd be interesting to have a discussion about, is this is a graph of Australia and the rates of obesity around Australia. So it's a bit hard to read, but the dark... Oh, I've done it again. I keep pressing that button. What have I done now? Here we go. So the dark red is rates of 70 to 79% of obesity. So almost 80% of people in the regions that are red are overweight or obese. And the yellow levels are sort of 40, I think it's 49 to 68. So there's some regions where we don't have data for, like far northwest, Western Australia, Western Queensland, far western New South Wales. But I think there's some really interesting things to note, that the areas that have got the highest rates of obesity are rural areas. So rural Western Australia, this area of rural South Australia, which is around Mount Gambier, and it's called the Greater Green Triangle region. Western New South Wales, Dubbo is right in the centre of that area there, and southwest Queensland. So I think that's fascinating. The other thing you can't see terribly easily in this graph, but is in that little square around Sydney, is that the northern beaches of Sydney have got an overweight and obesity rate of 14%, 14%, which is pretty much the same as, the rates in 1989. And so I just think that's fascinating. Should we all just move to the northern beaches of Sydney to solve the obesity crisis in Australia? So yeah, it'd be interesting to have a discussion, I think, around why there's such a huge discrepancy around Australia in those rates. So that's all I wanted to say. Thank you.
Thank you, Michelle. And we did talk. Yeah, thank you. Before tonight, actually, I've had brief conversations about going down the rabbit hole of human behaviour and what causes that, and I think that's probably another 4 science in the clubs that we can do next year. So think about those links between obesity and diabetes, and keep those even specific questions. I know I have a question about where triglycerides are stored, for instance, till after Rod has spoken as well. So Rod, over to you.
Thanks very much, and good evening, everybody. Michelle, when she started, introduced herself as an applied scientist instead of a real scientist. I think probably with respect to lifestyle diseases, applied scientists, or the science of application, is probably the more important of the 2 types. And the one thing that I do want to talk about tonight is just that. And the suggestion that reductionist science, and because we're in a club, I can go a bit beyond what I might do in a normal academic discussion, but the reductionist science is limiting the way we're understanding the problem, and we need to be thinking about complexity science if we really want to understand how to address what we're clearly not getting on top of if you look at those figures. So I'll introduce myself and a content area to present that, but that's the underlying message of what I want to say. The second thing that I want to say, and I'm going to borrow a scientific reference from John Lennon in a minute to back this up, but we're talking lifestyle diseases, and it seems to me from that graph the people with the lifestyles, northern beaches of Sydney, don't have diseases. So is this thing lifestyle diseases in itself a problem because of the way we're characterising the nature of this beast? John Lennon said in one of his songs, and I think he took it from somebody else but made more money out of being poetic about it, life is something that happens when you're getting on with your other business. And I suspect for most of us, life is what happens when you're trying to deal with the daily grind or the daily hassle or the challenges of the moment. Not many of us are there sitting on a jet ski taking selfies and say, this is the style that I want to live my life. We are a product of the circumstances we're in and the individual choice which we argue that people have to use to address this problem probably doesn't happen for most of us. We don't have the choices at our disposal to choose the lifestyles to address the problem at the individual behavioural level. So the rabbit hole of behavioural change, I've actually now taken on directly rather than to pushed off to 3 or 4 different separate meetings. But I want to do it from the perspective not of behavioural change. I want to do it from the perspective of obesity, smoking deaths, diabetes, are all the product consequences of the context in which we actually are living. Now, the topic, my particular research topic, is injury, largely because I spent my early years in an emergency department seeing about, 25, 30% of what was coming through the department were otherwise fit and healthy people, 1 minute, and severely injured, or injured, and up to the point of severely injured the next. At that time, we were saying, you were clumsy, you were lazy, you didn't obey the rules, you should have done it differently, and besides, it's chance, and insure yourself and there'll be no trouble. That was the time when we were killing more people on the roads in Australia, in Victoria, than we're now killing on the roads in the entire country. Because we shifted our thinking from an individual victim fault behaviour approach to how can we set a context in which the circumstances are such that those risk factors aren't there and that individual at that particular time of night doesn't hit that tree and kill themselves. Injury, and I'm using the term to cover everything that's not a disease in the sense that you currently understand it to be. So that includes suicide, it includes drug overdose, it includes road crashes. Injury in Australia is the leading cause of death under the age of 44. If you look at the global scale, road crashes alone are the 9th or 10th leading burden of disease, that's taking deaths and hospital morbidity into account, across the world, and it is expected to rise to the 5th leading cause by 2030. So not only is it a problem in Australia, it's a growing problem in the world. When I moved from South Africa to the US 3 years ago, and that South Africa was only for a short period of time because the position I had in Australia had an outpost in South Africa, I moved my risk of being killed on the road from 25 per 100,000 to 10 per 100,000 in Atlanta. And when I moved back here, it dropped to 5 per 100,000. Now, I drive the same way wherever I go. Fortunately, I'm an older, middle-aged male driving a moderately safe car, and my risk of dying now is a lot less than a lot of people's, but nevertheless, one does pick up the ambient risk of the environment we're in. And in South Africa, I had a very much higher risk of crashing. In the US, I had a very much higher risk of crashing than here, and here I'm much safer, although not safe enough. What level are we going to design our system? Where do we dial our system down to get the number of deaths that our system is perfectly designed to deliver? The system is not broken, it's delivering an accurate result. The system is delivering the result that some incentive in the system is maintaining at that level. And if we want to drop the lifestyle diseases, we have to work out where the incentives in our system are and work out how to dial down the frequency of the outcomes rather than telling an individual to make a choice every minute of the day that calculates their risk for that particular activity minus the benefit for that particular activity, do that calculation and work out which action they're going to take. If we talk about numbers of outcomes in a community as opposed to your individual risk from that activity, then we just need to design the community so that we can dial the numbers of those outcomes to a point that we're happy to accept. And I'll finish at that, but just with a reference back to complex systems versus risk reduction. Reductionist science tends to say we can break the problem down to its micro units, and in examining the micro unit, we can understand how everything's going to work. Complex theory tends to suggest that if you do that, you still won't understand how the aggregate of all of those elements are going to behave when put together. And it's the interactions between the elements that are as important as the characteristics of the elements themselves. And that if we want to understand how society is currently operating, how it's behaving, we need to not only look at the component parts under a microscope, we need to look at how people interact and react with each other and how the loops and the feedback loops occur so that we can find the best point of leverage. My area is injury. I have described a shift from the way people have looked for the broken part and tried to fix it to a point where they recognise that part will keep breaking unless we do something upstream to take the pressure off that part. If we have somebody at 2 o'clock in the morning giving the wrong drug to a patient because they've on a 36-hour shift and they're on their own, and the person who wrote the script scribbled, yes, that person is going to have been responsible for the misallocation of that drug. However, any other person in that particular circumstance would have also made that mistake. So blaming that particular person for the overdosed patient is not a healthy way to try and reduce the number of those outcomes in that community. We can keep replacing that person as much as we like. The system is putting stress on that particular part of the system so that that part will break and keep breaking. Understanding a system science approach tries to recognise the dynamics of that particular set of processes so that we can set up an environment where the risk factors for that particular outcome do not exist in the design of that engine. And those engines will run more smoothly with a better outcome and hopefully shift the sorts of figures that we've seen on the board that is continuing to go up despite our knowledge of the condition to something that starts to go back down again to how the country was 20, 30, 40 years ago.
Rod, while you have the microphone actually, am I correct then in looking at the difference you're talking about in the reductionist view and the reductionist science of understanding the mechanisms of the disease, the difference right up to the complexity science. The difference between Michelle's diagram, perhaps with the receptors and the cells and the insulin production, to Jacqui's view of the iceberg and those complexities, is that the kind of difference you're talking about, understanding those kind of physiological mechanisms right up to the complexities and interactions and confounding factors that occur there?
Yes, and certainly I probably wouldn't be quite as dichotomous in my discussion, except that to make the point, there's no one or the other. One needs to have the understanding of the physiological and the pathological dynamics of that. But if you handed that slide to somebody in the street, is that going to solve our problem?
So we're talking across a continuum here of everything. I agree. Fabulous. Burning, I'm going to throw to the audience. Jacqui, can I get you to come back here? Because I've done a time check. I feel like I kind of want to hand the microphone back to you and keep talking. It's 10 to 8. We're going to break at 8 o'clock. But for the next 10 minutes, I want any other questions that are coming from you guys. And if you do have a question, please raise your hand, wait for a microphone so we can capture them on video. So have you got any question for our panel members based on what they've just said? We have one over here, Michael, in the corner.
We're not taking questions from that person over there. That's all right.
Hi, I'm Kenneth. This is a question either to Jacqui or Michelle. If the prevalence of type 2 diabetes is so high in our population, does that mean potentially at some point in the past or in different environments that type 2 diabetes or the tendency to have it must have a positive effect, hence it becoming so prevalent and presumed in our genome? Could you imagine an environment where type 2 diabetes could be beneficial, or the physiology that could produce that?
I couldn't for type 2 diabetes, but I could for obesity, in that I think throughout most of human history we've been in an environment that's where our physiology has tried to stop us from starving. And so all of the mechanisms that are biological and psychological make us seek out food, enjoy eating food, eat more food. And so I think throughout human history there probably hasn't been a situation where the opposite of that has been an environment that the human body has been able to deal with. So that's why, I think your question is more relevant to obesity as such and the science behind that than type 2 diabetes. I don't know if Jacqui agrees.
That's a curly question. I've been thinking about it a fair bit, actually, in the context. You might remember I mentioned that these responses where we can develop new blood vessels to heal and to improve our cardiovascular function might be important for survival mechanisms. And so, for example, if you get mauled by a lion, you want to be able to run faster so next time you don't. Or if you're starving, you need to be able to have the ability to walk further to get your food, your water source. So those are kind of protective survival mechanisms. And I think it's interesting that they're actually, to a certain extent, reversed by the diabetic neuropathy. So I would be saying the opposite, that I don't think, the opposite. I don't see it as that's an optimal thing. I think it's almost...
I was just wondering if there's any evolutionary ecologists or evolutionary researchers, and maybe, Kenneth, we could pair you up with them in the break and you guys could talk about whether natural selection and for those things affects that. Are there any evolutionary scientists in the audience?
I'd like to have someone.
Great.
If someone knew different animals that are more likely to get diabetes than other animals, and you could wonder what that would mean in the animal's environment. It's an interesting question, isn't it? I don't know the answer.
Very. So, question mic down the back. Jacqui, you keep that one. There's a question mic here. Jacqui, you come back. That's ours. You can keep that one. Oh, you're the evolutionary scientist.
I am more than evolutionary scientist. I study genetics of aging, and I have did a lot of research from a certain angle in relation to all what has been said. But what I could say, actually, summing up a lot of things that have been said here, and I have published this in a paper on life extension strategy, which is the most important thing is stress. Stress is very, very bad, and stress could cause all sorts of genetic diseases and cause cancer, which is not good for health in general. The other thing too, which is to live on sub-starvation diet. You know, sub-starvation diet.
Like the 5-2 diet?
It's, you know, you could name it whatever it is, but you find a lot of people keep eating because they are enjoying eating. But it's very important to realize that, you know, I have enough, I'm going to stop here before I fill myself up. But there are a lot of other issues that we could talk about. Like some people are born with a certain kind of mutation that when they are at 7 years of age, they look as if they are 70. Okay, so we have to think about not just the genetics, but also the genetics and the environment. Something else too, which is very important, we have to make a distinction between average and distribution. We could have the same averages, but we could have a kind of different kind of distribution. I think
Of course, no, that's okay. But I am going to go back to your very first point and throw a question to the panel, and that's how would you define stress in this? Because, of course, we can define stress across so many aspects of this. And how would you say stress, in its various definitions, affects these lifestyle, and you can take it from diabetes, obesity, injury, or anything like that. How would you say stress affects these? And how would you define these stresses, I guess?
Yeah, I mean, I think stress as a term is very, very difficult to define.
Is it a bit like health? What's health?
Probably, probably. But yeah, certainly sort of stress is associated with a hormone called cortisol. And we know that higher cortisol levels are associated with increased inflammation. And Jacqui was talking a bit about how inflammation causes a lot of the problems. Cortisol is also associated with some of the other. It's got a very similar structure to some of the other hormones in the body, so it can also then interrupt those normal hormonal functions as well. So yeah, it's certainly a very significant part. I don't know. Are we more stressed now in this sort of this era than the cavemen were when they were being chased by lions? I'm not sure.
Well, I will ask you, what is the data like on cortisol levels from 30 years ago compared to today? And if we're defining stress as a factor that contributes to lifestyle diseases, whether it be we're stressed and we have a glass of wine and sit on the couch, as opposed to go for the half-hour walk that we need to do, as opposed to increase cortisol levels because of other reasons.
Yeah, I mean, certainly exercise decreases your cortisol levels, and that's one of the benefits of exercise, is that it lowers your cortisol. I don't know whether having a glass of wine lowers your cortisol. Having a glass of red wine is okay. The resveratrol in it has good effects on anti-inflammation. I don't know. Do you have any data on cortisol levels over time? I don't know that information. Yeah.
Can everybody have a quick stretch and a move? Move your limbs, please. I'm serious. Get your cortisol levels down. Get your body moving. Good. Rod, did you want to comment on stress levels and their and the attribution of stress to lifestyle disease?
Yes, and I might carry on with my take. There were 42,000 Americans died last year from opioid overdose, largely initiated from probably a prescription opioid habit that, when the prescriptions started to be restricted by the system, seemed to convert to a heroin and fentanyl habit, and the deaths increased even more dramatically. It's happening in Australia to a lesser extent. The recent paper suggested that rural Australia had a greater problem than urban Australia in terms of opioid misuse and consequent death. When we're talking stress, I'm not dealing with the cortisol individual physiological stress here, but one has to ask why in a country entire generations almost have somebody in the family, one of their friends, who've died from a misuse of a medication which to a large extent is there to address a psychological consideration. So yes, it's indirect answer to your stress question, but it also backs up this notion of systems, because even though we knew in 2006 in the US that there was a problem, and we're now starting to pick it up in Australia, in 2017, that's 11 years later, the rate of deaths is actually faster than it was in 2006. And that problem actually started in 2000. So whatever it is that's driving this, whether it's coming from social dysfunction or destruction or social strain, or whether it's coming from the other end of the spectrum with highly industrialised pharmaceutical systems, there is something in there which we need to tap into to stop these inexorable rises.
Do we know about many correlations? What else is increasing? There's a lot of other things that are increasing at the same rate, and what other correlative factors increasing with those increased in deaths?
The single most obvious one is the increasing number of prescriptions. They track each other exactly until about 2009-10. And those prescriptions flattened out because the interventions were put in place to stop that part of the problem. Unfortunately, though, the prescriptions in Australia are going up in the people over the age of 65. The deaths are going up between 25 and 45. So there's diversion in the system somewhere. So it's not just that the people who are being given the medications are having an accidental consequence. It's that there's more in the system, people are more able to get hold of it somehow, and those who are in the different part of the demographic are actually dying.
Jacqui, did you want to comment on that? I just saw you had a thinking moment there.
I guess I was just trying to put a bit of a positive spin on some depressing statistics. But when you think about it, if we think about all these diseases that are caused by lifestyle factors, it means that the treatment is well within our grasp. It's not like we're talking about diseases we don't know what's causing, we can't cure them. And I think that's pause for hope. And I guess on the mention of medication, you might have mentioned, I talked about the impressive reduction in development of type 2 diabetes in people who are high risk for diabetes with just simple lifestyle modification. As I said, if that was a drug, a pharmaceutical company would make an absolute fortune out of that. And it might be a bit controversial, but I might argue that because a lot of those cures aren't going to involve drugs, we may not get that push, I suppose, to promote it. If there's a new incredible drug being released for asthma in the past, occasionally you might see an ad on TV saying, go see a doctor, there's a new treatment. But I think we're getting better at that, marking that message, but I think because people aren't making money out of it from a private company point of view, that may be relevant, yeah.
If there's anyone in the audience that wants to go down the road of big pharma and it's that's absolutely fine, but I just don't want to get too into that kind of thing. Can I then pass back to Rod and ask about the systems research, and correlations are one thing, yes, but teasing apart cause and effect in those complex systems is an entirely different thing. Do you feel that we rely on the reductionist science and the mechanisms and the physiological mechanisms of these things because it's so difficult to tease apart these factors in a complex system kind of sense? Would you want to pass that thing back? Did that make sense?
No, it made really good sense. And again, I'm going to take the counter position only in order to keep the debate going. I'm not quite as confrontatory, perhaps, in my real beliefs. There's a real push for evidence-based medicine. Our interventions have to be based on what's essentially randomised controlled trials, because they produce, meta-analyses of multiple randomised controlled trials, or grouping the results of randomised controlled trials together, because they're the ones that have a methodology that allow us to exclude any other alternative possible explanation other than the one that we think is going on. So we're starting to do randomised controlled trials to drive population-level interventions, but our trials are done in environments which are so highly circumscribed, we can only actually manage some of the intervention variables in our trials. If the intervention is how the pharmaceutical industry or how the general practitioners or how the physical activity industry operates, you won't find that in a lab. So our search for evidence is really just a search for certainty, because we're very uncomfortable with uncertainty. So we now come up with an incredibly certain piece of fact, which has simply moved the uncertainty back out into the implementation phase, where we can never be certain. In fact, I can quote Einstein to beat John Lennon as a quote, that we might have we may have the maths, we can be certain about some things, but no, I'm going to miss this one out. There will always be uncertainty in the system, and however we trap it, all we do is we move that somewhere else. And we can have one or the other. We can know where something is, but we really don't know how it's going to work in another context. So, and even in most of our reductionist science, we work in correlations anyway. So in the real world, we've just got to be arguing on a grander scale and say that this seems to be associated with that, and let's try it and see. In fact, join the business world in rapidly prototyping, make a change, look for the consequence, make a change, look for the consequence. And there are some cluster randomised controlled trial methodologies now which are starting to approximate that process.
Great. And in fact, on that note, I'll let you ponder the Einstein quote a little bit more as well, Rod. I'm going to say have a break, stand up, grab a drink. We're going to get some more finger food out. Form a group of about 4 or 5 people around you to reflect on some of the things that these guys have just been talking about. And we're going to start trivia in 5 minutes.